So I'm just going to type it in your file, delete in a moment. So, you learn a few design recipes, right?
Yeah.
So we saw for data definition, we saw one for function, we saw one for abstraction. Why is that Copilot trying to autocomplete for me?
You can disable it.
Is
Yeah.
it bottom right?
There. Yeah. And then inline suggestions. Uh, yeah, under that. Yeah. And like uncheck everything.
Dude, I feel like if you didn't tell me this, it would taken me a while to find out. Like, if I looked at inline suggestions, right, I wouldn't have figured out that's where I have to go. Okay, anyway. Okay, yeah, right. Um, abstraction, and then so see, it killed my train of thought. I was thinking, and then it made me stop thinking. All right,
Yeah.
there's accumulator and generative recursion.
Mm.
Okay, data definition. This you're not gonna like create a. I don't think you're gonna create a custom class or custom struct, but this is useful for thinking about how to encode the problem statement into
Mm.
useful representations. Okay,
Okay.
so that's how you're going to use that function. Uh, I guess like this is probably going to be one of the least useful ones, but I guess being clear about the flow of data, we'll get back to this. I think this is better if we go through as you work on problems, you'll see this more clearly. Abstraction, useless. You can forget about this.
Okay.
For competitive programming, it's basically useless because like I don't think you're gonna have repeated code. Abstraction is when you have repeated code. I don't think that's the case for you.
Yeah.
Accumulator. So this one is actually useful. For accumulator, you're going to have
Mm.
you're probably going to like reassign or mutate something throughout like maybe through a loop, throughout a loop, for example.
Okay.
So like the loop is working on the same thing again and again. So that's like it's carrying over context, right? And
Right.
as you traverse the loop, you're gaining more information, right?
Okay.
So you're accumulating. So for whenever you're inside a loop, you are like doing stuff, you're changing an accumulator, I'd like you to follow the four statements. So in practice,
Okay.
I don't want you to actually spend time. Let's say you're in a competition. I don't want you to actually write the four statements, but I want you to think them.
Mm.
But for our learning purposes, I'd like you to write out the four answers. So like if you forgot, it's like what does it represent? What is it? How does it start? How does it change? How is it used? Okay. So like for now, I'd like to explicitly answer these four questions. For generative recursion, at least for it's probably going to be in loops again. You're not going to actually use recursion. So I'm going to remove recursion. I'll say generative. Um, so this is like when you are generating new data in a repeated chunk of code, let's say. Again, answer the
Okay.
three questions. So what's the base case? What's the generated data? So in the case of recursion, you ask what's the generated recursive data, but in loops, you just say what's the generated data and why is the base case guaranteed. Okay, this one, sometimes I think it's enough for you to just say it out loud. I don't expect you to write stuff because I think a lot of times it's very simple. But I'm not sure how difficult your questions will be. You may find times where it's actually quite difficult, in which case I do want you to write it out.
Okay.
Again, in competitions, don't worry about. Like in competitions, I want you to think about it, but I don't want you to like waste time writing it out.
Yeah.
Okay, so here's the thing to notice. Accumulator and generative, these two are your bread and butter.
Okay.
especially when you're like trying to solve the problem. These are your bread and butter. Accumulated and generative, I didn't teach this, but I think what you'll find out is that these two are can actually be very much related. You know the idea of generated data and generative? Actually,
Yeah.
can you see my highlights
Yeah,
on
yeah, I
your...
can.
Okay. So generative data, this can be an accumulator.
Mm, okay.
We didn't see examples of this. We will in the future when we continue learning new topics, but I think you will see this in as you solve this problem. All right, any questions about this before we begin?
Mm, I don't think so. Yeah.
Okay, I'm going to move this
Like,
to intro to, yeah.
okay. So, like, are you going to like do this problem or like learn about, I don't know, algorithms and stuff?
I think I want to see you solve this problem first because I don't think you need special algorithms for this problem.
Okay, yeah.
I kind of want to see how we can apply these few things to what you have been doing in the past. That's my goal now.
Hmm.
Yeah.
Are you sure like we want to do this problem because I like know how to like solve it?
Do you really know, like, when you solved it, do you solve it on your own or do you solve it while watching a
Yeah,
tutorial?
I solved it on my own
Okay.
eventually. So,
Okay. Do you have another problem?
hmm, I don't think so, but like definitely not in English. So,
Oh, let me think about this. Well, is there a problem that you have not covered yet? I know it's not in English, but like you could explain it to me in English.
hmm, like
That isn't trees or graphs. So any problem that isn't trees or graphs.
I will check, okay?
Okay.
Hmm. I don't want like to have some really easy problems, so
It doesn't have to be easy. Could be difficult.
yeah, this sounds easy. This sounds easy to. Uh, hmm. Are you looking for some problem or are you just waiting?
Oh, I'm just waiting. Is there any place I could look for a problem? Do I just Google it?
Yeah, I think there is some on
Okay.
Yusako.
What? US Sako? Is that a
You
Polish thing?
what?
Oh. Oh, wait, this is a US thing. Okay, never
Yeah,
mind.
USA.
Okay.
Hmm.
Training. Okay. What? Array. Oh, so you saw array. Okay. Have you seen Hay-Bale stacks?
What?
Yeah, there's a problem called Hay-Bale stacks. It's an open problem, like one of the early rounds problems.
Can you
Okay, I'll create a
send
new
me the
file
link?
called Hay-Bale stacks.
Okay.
Hay-Bale stacks.cpp. And then I'm gonna put the link at the top.
of course.
There we go. Okay. Actually, yes.
Oh,
Have you done this?
I, I, I did nothing from USA code, so
Okay, good, good. All right, so let's do this. I honestly don't know how difficult it is. I haven't read it. Okay.
uh,
Could you? I want to like read your thought process as well. As you read the problem, could you like read it out loud and tell me what you're thinking?
can I translate it to Polish?
Oh, sure, yeah.
Okay, so Parmen John has n stacks of tables, right?
Hmm.
Uh, where n is half, max half a million, right? And I uh, I can read it in English, it will be easier. And I stack contains A of Y tables, okay? It wants to remove all the tables that have M cows available, all those tables, okay? And he has M cows to help him, okay? If he had the if cow will repeat the following S times for a cost of C. Oh, okay. So we will like definitely calculate the cost, right? If the stack contains at least P of I tables, then the cow will remove one table. Okay, if the stack contains less than P of I table, the cow does nothing. Okay, for each stack, FJ wants to remove all the tables in it. He will do this by hiring cows in a sequence, possibly the same cow more than once until the sack becomes empty. Have FJ determine for each stack minimum cost to empty it. Hmm. The first line contains the number of independent case tests each time. Okay. The first line contains integer n. Okay, the second line contains an integers and there is some cows. Okay, mm, there is three and there is four. Uh, okay. Hmm. Do you consider it to be like hard?
I suspect it requires a technique that we haven't covered yet.
Hmm.
Yeah, this might. Honestly, I should read up on like is this a competition you're preparing for? US Eco?
No, no, no. Yeah,
It's not okay. It's
not
just where
really.
you're
Yeah.
getting problems. Okay.
Yeah.
I don't know the solution, but I have a feeling it may use a technique that we haven't covered.
Okay.
Okay, but okay, based on what you read, can you tell me like what are your thoughts? What are your first thoughts?
Like we'll need a lot of loops. Not
Okay.
yeah, but really, uh, like we need to figure out which cow is the most affordable, right?
Okay.
Uh, uh, yeah, I think we need like a kind of graph for this. So,
What do you mean by graph?
mm, wait, like uh, the nodes would be like the number of hays, right? Hay bells, right?
Okay.
Uh, and like we must use like directed graph to like uh, check what weight like the weight of a uh, what was like uh, the edge will be like the cost that we need to uh, like
Mm.
take after using each cow.
Mm. Okay. Okay. So that's how you'd approach it. You would use a graph.
Yeah, I think
Okay.
so.
But, okay, yeah. I think this is it uses things we haven't covered yet. We haven't covered graphs. So I'm
Yeah,
gonna say we'll skip this one for now.
okay.
I would normally say oh implement the like the brute force solution, but I don't think it's a good exercise for us anyway.
Yeah.
Okay, so I
US
give you a bad problem. I should have read it first.
US Open. I think it's like a hard
It's harder.
competition. Yeah.
Oh,
Mm.
damn.
You have something. Oh, I can send you on. I have sent you on.
Okay, you got something?
No, no. I have like a list of problems
Okay.
from a guide. Okay, and you have like categories on the left.
Oh, huh. Wait, is this high school level?
I don't know. Maybe not.
Okay, wait, let me read the USA code age group. This looks like for college, man.
Yeah.
Pre-college, so yeah, high school. Wow.
High school. Yeah.
Wow, this is crazy. What the heck is game? Oh, actually, game might
Oh,
be a fun one.
yeah.
What is
Maybe not
stone?
like the 2016 insane.
Okay, let's do it now.
Yeah, yeah. Uh, it's a gold, okay, so it's there's like divisions, and I think I would like be in silver or something.
B or C?
Eh, yeah, like
Wait, where do you see B and C?
what I would be in silver, and this is gold, what you have
Wait, you would be
checked.
in, sorry, you'd be in what, senior?
Silver.
Silver. Okay. Wait, what is
Silver.
gold and what's bronze skill? Is it difficulty?
Yeah,
What is
yeah,
that?
yeah. It's like
Oh, section.
oh, section, right?
What the heck? There's no, what? Wait, what is the difference between the three?
Like it's difficulties, right? But
It's difficult. Wait. There's two notions of difficulty. There's
yeah,
the easy,
yeah,
normal, hard, and there's
yeah,
also bronze, silver, gold.
yeah.
Okay.
There's like stages, and like the first is bronze, then silver, and
Dude, there's a lot of sections here, man.
yeah, there are
Wait, did they expect, dude, did they expect high school students to do all this?
maybe
Bro, that's
if someone
crazy.
is like dedicated.
Dude, that's crazy, man.
Yeah,
Okay, you know what?
USA is like competition of rat chasing.
Dude, like, dude, my college classes are like don't even have this much things.
Okay,
What the
it's
hell? What the heck is cactus? Wait, what's a section called cactus? Okay, okay. To find a good problem for you is very difficult. How about this? You and I will do some research. We'll try to get some. We'll accumulate some problems to practice.
okay.
For now, why don't we let's just explore more stuff with C++. plus plus.
Yeah, why not?
Yeah. For now, yeah. Just yeah, because right now it's not worth our time just looking through all these problems. There's so
Y-
many.
Yeah,
Okay. All right. Um. Actually, okay, also we need to set a goal. So like, what's your goal? What's your aim? Because you mentioned you want to get into like competitive. You're preparing for the Polish competitive programming something.
yeah.
What's the standard for that?
Mm, like you want me to show you like the questions for it or
Like,
the
is there a check?
problems?
Like US Seiko, they show you a list of the kinds of problems they would have. Is that an equivalent for your Polish thing?
Mm, no, I don't think so. I like uh, there is just like problems from like past years, but that is it.
Okay.
That's
Uh,
it.
so they're not as detailed as US Seiko, right? They don't detail the
Yeah,
expectations. Okay.
yeah.
For homework, I want
Like
you to research
yeah.
their past problems, and I want you to write down a list of things you need to know.
Okay.
And how does the Polish thing work? Is that like you have to sign up for a competition, you show up for the competition? Like, how does it work?
So like uh yeah, we sign up for it, and we have like uh three stages, okay?
Okay.
So like in the first stage you do the tasks in home. So most of the people like last year I heard because I didn't participate last year. I
Okay.
heard that most of the people were using like AI or something. So
Okay.
they like uh got to the stage two, but they couldn't do anything at stage two because they didn't know nothing, right?
Stage two, is it like in person?
Uh, yeah, stage two, we like come to some place, and it's like we stay for for the night, and it's 2 days long,
Okay.
and we have like 1 day to do like I think we have like 5 hours in the first day to do like the first problem, and the second day also, right?
What? 5 hours to do one problem? What kind of problem is this?
I can show you like
Is it a hard problem? How is it 5 hours? Dude,
maybe you
like
need.
a normal work day is 8 hours, You're spending like 5/8 of a day on what the hell?
Yeah,
Bro, what are you expecting of high school students? Like 5 hours?
Crazy, right?
Is the problem hard?
I can like show you and translate the
Okay,
problem to. Do you want like the hardest day or the like second?
okay, okay. Can you show me? Can you give me all like build up in complexity?
So like the first day,
Okay, give
right?
me the first day for now. Yeah.
Okay, right,
Wait,
of
so it's
course.
multiple days, and like, are you there for
N-
all days, or like you can
No,
get kicked out
sorry. I meant stages.
stages?
Sorry.
Okay.
Yeah,
Wait,
yeah.
so stages? Is it like these stages are months apart?
Like yeah, like 2, 3 months apart, right? Yeah.
Okay. And so how
Okay.
many problems are in a stage?
Mm, like okay, so the first stage really differs from another's because you did at home, and I think you have 12 days to do like six problems.
Okay.
Yeah, six problems, and then you have uh, mm, oh, so okay, so it's my bad, I think. We
Okay.
have 5 hours to do the second stage. We have like 5 hours to do or 6 hours to do uh two problems, and the second day also, okay. And we have like a test day before that where the our like problems don't count, is just to prepare us for the real deal. Okay,
The heck? Okay.
and the third stage we have like also 2 days, but three problems each day. Okay. Yeah.
What the
Um,
hell? Okay, all right, yes. Can you give me a bit of all the stages? Just a little bit of each so I can get an idea.
yeah. Can
But
I use like
yeah,
AI to translate that for you?
yeah, sure, yeah. And I definitely need you to do more research at your own time about what's expected of you, so I know what to give you in these sessions.
Of course.
When is stage one?
I think in December, right?
Okay, you
Yeah.
got time then. You got a
Yeah.
lot of time. Okay.
Uh, can I like share you my
Oh, screen. Yeah.
no, not screen
Oh,
really, but you can just
okay. I don't know what that
my
is, but
AI,
okay.
yeah. Oh, so wait. I think I will share you another one, so I will like do all days, right? Do all stages. Uh,
32nd publish OI stage one. You see this. Then zero more moves are performed. Each move two numbers that are summed and sum up to an even number are chosen. Oh yeah, by the way, whenever you get questions like minimize the cost or remove as many elements as possible, that's those are like optimization problems.
okay.
So it's a class of problems, and that's why we haven't covered it yet, which is why I also wanted to ignore the previous problem. So this guy removing pairs of numbers is an example of that.
Yeah.
Um, I believe. Let's see how many two natural numbers A, B represent the sign and sequence. So that's it.
Like the first stage, yeah. The first stage is not that hard. Yeah.
Okay. All right. So I just looked at stage one, is it? Okay. I guess that makes sense.
Yeah. Okay,
All right.
so
What's the next?
uh I will share you in just like 10 seconds or something. And
Okay.
I don't know. I will share you like both the second and the third stage.
Okay.
Okay. So you have it right here. There is like it's the whole chat, so you will need to like scroll. Yeah, so it's the
Wait,
first.
when you send me a new link, does it not update the old one?
I don't think so.
Okay.
So it's the second stage, right? Yeah.
Baitasar.
Yeah, because there is a Polish name called Baltazar, and
Okay.
Bait is yeah,
Yeah.
Bait, yeah. So Baitazar, it's yeah,
Okay, Baitasar.
like
Okay.
a game of words, right?
I see. It's not going
Yeah.
very well for him. One of the problems.
Oh, so yeah, yeah. I think it's wait. Is like translating, or it's also like doing things that it shouldn't do, because I don't think we get. Yeah, okay, so it's okay. The AI is working correctly. Okay, so zamiana, the action is change. Okay, it's change. I don't know why it didn't translate that.
Oh my God. Okay.
This is stage two.
When a book's P and PJ.
Oh, you also have like the year and the months on top, so you can see the difference in time between all stages.
Hmm.
Do you think like it's possible to prepare for that in like 4 months?
For stage one, 100, the stage one, I think you can already solve it, man. This is stage two, right?
Yeah, this is
Uh,
stage two.
this, okay, the idea of an inversion is a mathematical property. So if you know a bit of mathematics, you have an advantage. But okay, let me see. Hmm. Okay. Let me read it. I'm guessing you want to do the IO way. You would do this the IO way, I'm guessing?
What?
Like, how would you solve this? Would you use the IO or would you use a library?
Uh, yeah, I think IO. Yeah,
Okay.
yeah, 100%.
Well, what is DAJN?
Uh, give n die is give
Give, okay.
DAJ. I don't know why
What
it
is return
didn't.
value?
You are asking me? I
Like,
didn't even read the problem.
oh, you didn't read it. Okay, I thought you were reading with me, bro.
No, no.
Okay. I didn't read too fast. So wait, this is, oh, it's assuming that you're using,
Yeah, because you can
what?
solve the Olympiad in Python also, but it's
Wait. If you use the library, isn't that an advantage? It's,
maybe, maybe.
yeah, it gives you an advantage, right? Because you have functionality you can just use.
Yeah, but uh, I think it was also at some point that you could like use the pi. that is given from the library or read like write your own pie, but who does that, right? It's like
Okay,
you always use the library, yeah.
I see.
Yeah. You can check the stage three.
No, sorry, I just want to understand this one before I move on.
Okay, yeah,
Improve
of course.
tuning.
I definitely want to understand it. So
It's the number of inversions after performing the swap. So you're swapping these two, you get 3-1. How is that 3? Okay, I'm not gonna lie, I don't even understand this problem.
crazy,
The
right?
return value is the number of inversions after performing the swap. How would, how is the inversions decreasing when the arrangements are the same? Wait, am I? Oh wait, the arrangement. Wait, maybe the arrangements are changing. I'm just not reading this right. 3-1. You're swapping 1-2. If you're swapping position 1 to position 2. Oh. Okay. I will say a little bit about this problem, the idea of inversion. So at least in mathematics, I don't know in programming, but mathematics, a good thing to keep in mind is the idea of um when you take an action, what is it about the problem that's changing? Sorry, what is it about the problem state that's changing?
Yeah,
So the key idea to keep in mind here is the number of inversions. When you take an action, how does the inversion change? In the case here, they seem to be doing a lot of work for you. They tell you what the inversions are.
yeah.
But what I'm curious about this problem is if you don't use the library, how would you know? Would you just it just I see, it just gives it back to you. Okay. I see. Okay, what's the
Like
next one?
the good thing is that like you just must scroll down a bit.
Oh,
Yeah. The
oh.
good thing is like I have like 3 years that I can try to compete.
So are you the youngest age group? Is that why?
Not really, because I could have tried like last year, but
Okay.
yeah, I
Wait, do
didn't.
are all ages that get the same problems?
Yeah, yeah.
Okay.
Funny,
All
funny,
right. So
right?
okay, stage
Yeah.
2, I feel like it's not very difficult. And what, you get like 3 hours on it? Is that the time?
Wait. You will read this. I will like
Okay.
confirm the time limit.
Okay.
Uh,
Does not want to work in the same team. Hmm. Okay.
Um, yeah, so I have 5 hours to complete two tasks. So 2.5 hours about for one task, right?
But you have the freedom to distribute the time. Like you can
Yeah,
work like one
yeah,
hour,
yeah,
right?
yeah,
Yeah.
yeah, yeah,
Okay, they're quite generous with the time. All right, stage two, I think should be good for you. Stage three is a little bit more difficult, but I don't know. I feel like if you okay, like if you compare this with the USA code, right, this is nothing.
yeah.
So yeah, no, I think it's totally doable.
Hmm. Okay.
By the way, I sometimes I do this. I don't know if this is recommended, but I go straight to the input and just read the input. Yeah,
Yeah,
like
it's
I didn't even read the problem statement. I just went straight to the input and I have an idea of what's happening.
yeah, sometimes it's like easier to do that, but I wouldn't do that in like real competition, right?
So what I do is I read input and then I go to problem statement because I feel like the problem statement is just a crap ton of information you don't need.
Yeah,
Input is
yeah.
like there you go. Here's the stuff. Okay, and then examples. Input data. Blah, 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 blah. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They didn't lie. Okay, the correct output is 11. Okay. Okay, okay. A lot of algorithms. A lot of algorithms. Okay. And would you say these problems are representative of the kind of problems you face in each stage?
Like I picked them at random, really,
Okay.
but they are from day two, so they are supposed to be harder, right?
So wait, these are all day twos, the one you just shared
Yeah,
with me?
yeah, yeah. You have
Okay, can we see day three?
is
Sorry,
there
stage
the
three.
no, no, they are both like the first one is stage two and the second one is the
Stage
stage
three.
three. Yeah.
Yeah, no, I think this is very doable.
Okay.
Very doable, yeah. Okay. Okay, we got 13 minutes left. Um, hmm, I let me think about this. How do I want to
Okay. So
yeah.
the first stage, the it starts at okay, okay. So it's uh hmm. Okay, starts in November. Okay, really, 12 November. Okay.
Okay, you got 3 months.
Yeah. Uh, the second stage in February.
Okay.
The third stage in March. No, no, not
One
March.
month.
April.
Okay,
Sorry,
so they're
April.
like 2 months apart, all right.
Yeah, 2 months
And
apart.
it ends with stage three.
Yeah, this is stage three. Yeah,
Okay.
yeah.
Okay, and like how does the competition work? Like let's say you've passed it. Is it like the person who completes the problem first is ranked higher?
No, no, no. You just have to do all correct, right?
If you do all correct, then that means in theory multiple people could tie for first place. Is there such thing as first place?
Yeah,
How do you get first place?
like, mm, hmm, quite good question, right?
Like, yeah, if like two people solves all the problems perfectly, then like are they both gold medalists?
Hmm, wait. I'm looking at the like finalists, and
Okay.
there are actually six people with the same score.
Okay, so you can tie. All right.
Yeah, yeah.
All right. Well, what's your goal? What do you want to get out of this competition?
Like this year,
Yeah.
I would like to like get into like stage two, but you could always use AI for stage one, so it's I'm not hoping that I will get into stage three because that like takes some practice.
Okay.
But just to try it out, really, yeah.
Okay. That's a good mindset.
Yeah.
All right. So yeah, this is the one mindset I want you to have for this competition, and not just for this competition. This is the mindset I want you to have for life. Don't try to, do not chase winning. Do not fear losing. Do it to learn. Okay?
Yeah, of course.
Because if you chase winning or you're trying to avoid losing, regardless of what you do, you're doing it with fear. You,
Yeah.
you can't give it your all when you're doing something with fear. Just go in with the mindset that you are growing and you're learning. That way you can give it your all.
Yeah. If
All
if
right?
I would like prepare for this for like 4 years or so, I would be stressed, but 3 months is
Like
like
in okay, I don't want to give your hopes up, but in theory, right, if you're really diligent, right, you can like get to stage three. Because like I'm looking at this stage three problem, you're not far off from it. Like I don't think you're far off from this.
really, I
Like yeah.
wouldn't say so, but
Like I don't picture someone that has to be like like doing 8 hours a day for 3 years. That's not what I picture. Like this is something like you spend 1 or 2 hours a day. You can even have a day off. If you can do this consistently for a few months, you can actually reach this level. But here's the thing, I'm only looking at one problem. There might
yeah,
be more problems, right? So I'm not
yeah,
entirely sure. Uh okay, so like especially in competitive programming, what's important is that you need to be able to identify what kind of problem this is and what tool in your toolbox you need to use to solve the problem, right?
yeah, right,
Yeah. So for example, you might look at this like I'm looking at this stage three problem here. You're saying, oh, some employees want to work with other employees. Other employees don't want to work with other employees. That sounds like a graph problem. For example, I'm not saying this is a graph problem, but that might be an idea that you have. So and then you explore that route. If I treat this as a graph problem, what can I do? Will this help
mm,
me? Right?
yeah,
Uh, right. So my goal for you now. So initially, I wanted us to just try out some programming problems to get you to practice what we learned on something you can do in competitive programming. I don't think I'll do that in these sessions. How about this? At your own time, whenever you feel like it, try stage one problems, try stage two problems. But whenever you get stuck, then we can do it in our sessions. Otherwise, I think I'll just continue giving you more topics. Because I feel like right now you just need topics. You need tools in your toolbox to solve these
yeah,
problems.
yeah.
Okay. We have 7 minutes left. What can I do with 7 minutes? I need to, I think it's time to introduce you to, or should I show you more C++ stuff? In this competitive programming, do you ever use pointers?
Mm, I don't think so. I don't think
Okay, so
so.
yeah, I won't go into pointers then.
Yeah, like maybe reference, right? But
If you do use reference, why would you use reference?
to make it faster, right? To not make a copy and pass it to a function, right?
Mm, that's not necessarily true. It depends.
Okay.
Yeah. When you run code, are you able to see the timing, like how fast the code runs?
Not really,
Okay, never
but
mind.
I think there is a like on the second day, on the second stage, I think we will have computers with Linux, and there is a command to do that.
Yeah. Okay. It depends how you're compiling the code, and like it depends what you're passing in.
Hmm?
In most
We are
cases,
going
like
to, there is a GCC compiler on.
yeah, like for example, like depends on what compiler flags. If you run with maximum optimization,
Oh,
it
okay.
might just get. Remember we talked about inlining?
Yeah,
Yeah, you might just get inline. Like there are like so many factors, and you can't know for sure unless you time it. But it's not a guarantee that when you put a reference, it's actually faster. Like it's not a guarantee.
okay.
Um, yeah, but like, wait, so how does this competition work? Like, does the speed of your code matter, or like as long as it passes the time limit,
Yeah,
at,
it really matters. It really matters. You have a time limit at, I think you just need to scroll up and time
yeah,
limit is
I saw
always,
that, but like,
yeah,
but here's the like, if you use the correct solution and you don't use
yeah.
a reference, is that really going to make a difference to a correct solution with the reference?
They, they don't check like the code.
No, I mean, but like in terms of timing, like
Oh,
would the time
okay.
saved by using a reference really make a difference if you have the correct solution?
Hmm. I don't think so. Yeah,
Okay,
it's so tiny difference, right?
okay. Anyway, but I'll leave it up to you. There is something
Okay.
about reference though, is that you might accidentally like reassign a value to that reference if you're not careful, but like I don't think you'll do that. Anyway. Mm, what STL data structures do you usually use?
Like, of course, vectors, right?
Okay.
Pairs is para STL,
I
right?
think so, yeah.
Yeah.
Oh, okay.
So and maps, right?
Like which kind of map? Like ordered map?
Uh, Both
Okay.
and unordered map is like faster, right? I think so.
Yeah, I mean, it depends on your task.
Yeah,
If like the order
yeah.
of the key values don't matter, then you should use that. Yeah.
And asset, and I think that's it. Yeah, and uh, stack, right?
Okay, why would you use stack?
No, not stack, not stack. A stack or
A deck?
a deck. Yeah, right. A
Okay, so
deck.
why would you use deck?
Deck.
Yeah.
Mm, is it's not like used in uh BSF?
Okay, so PSF. Okay, yeah, it is. It can be.
Yeah,
DFS also, you can use a deck. Yeah.
yeah.
Okay. All right. So
And
yeah. So
I think that's it. Yeah.
okay. At your own time, I'd like you to just try stage one problems.
Okay.
I think even at your level, I think they're trivial for you. But give some a shot. Just pick and choose. If you run into any
Trivial.
once,
Trivial. I
yeah.
think they're pretty hard. Okay.
Okay. So do some practice with them. Try them out. If you run into any problems, we'll go over them together. But
Mm-hmm.
like, I don't know what problems to give you. You're the only one that would know best, right? Because you know yourself.
Yeah.
Okay. So at your own time, do that. If in our sessions, I'm going to f move on to our next topics just to tease you as to what our next topics are. We're going to focus on trees next.
Okay.
Trees are like lists, but instead of each node having one children, each node has two children, depending on
Yeah.
the
Right.
tree. For a binary tree, you're going to have two children. Um,
Okay.
and then you got some advanced trees, like you have n-ary trees, where each node has an arbitrary number of children. Anyway, yeah, so we'll get to trees. Once we once we finish with trees, we're going to move to graphs, and then I'll introduce graphs for a little bit, and then we'll move on to some algorithm like algorithmic thinking. So technically, we've been doing algorithms, right? Algorithms is just step-by-step computation. We've been doing that all the time, but we're going to go into some ideas, some tools you should have in your toolbox. For example, have you heard of the term dynamic programming?
I have, but I don't really like
Yeah.
got into it. Yeah.
So dynamic programming is essential, essential. You really need that. And
Okay.
so that's an example of a tool in your toolbox, dynamic programming. You
Yeah.
need to be able to identify that the problem is of a certain class, and that dynamic programming is a good tool to solve that problem.
Okay.
All right, okay, let's leave it here and we'll continue next time.
Of course. So see you like next week.
I'll see you next week, Simon. All right, bye-bye.
Yeah. Bye.